Alright, so the sample test, as always, I probably don't need to remind you of this, I hope, but this is the perfect study tool because the sample test should show you exactly what types of problems you got to be ready for on the test. It's basically like another version of the actual test you're going to take. So if you can do the sample test with a lot of confidence and correctness, then you should be just fine. So here we go. Here's a quick rundown of this sample test for Chapter 3. Question number 1 wants you to solve a system of equations by graphing. Hence the word equation. Like there's certain things you got to be able to differentiate between, equations, inequalities, something that has absolute value in it and therefore is going to be a v versus something that is just linear in nature, so it's going to be a line. But anyway, so number 1, even though, because when by the time we were done with this whole chapter, this method was like almost seemed prehistoric or out of date, you know what I mean? Because after we learned the graphing method, we learned, the substitution method and the elimination method, which were like pretty much objectively better, right? More reliable overall and stuff like that. But I still want you to do number 1 by graphing. So I don't want substitution. I don't want elimination. I want the graphing method, which just means that you're going to graph both lines and see where they cross, or if they even cross at all. They're going to cross, spoiler alert, or hint hint. But so that's what you're going to do. Now this one was good to go. Your pink line with your y-intercept of 2 and your slope of -1. Sorry about that. But this other line you have to first solve for y. Add 6x, divide both sides by 3, and so you end up with this, and so you have a y-intercept of 2 again, and a slope of 2, which is like up 2 over 1. Anyway, so you draw your two lines and you realize that these two lines intersect at the point 0, 2, and so that is your final answer. You have to specify. Don't just graph the lines. Remember that the whole point of it is to figure out where they're going to cross and identify that. 0, 2 is the solution. And by the way, you should have attempted this entire sample test before going through this video, as needed, checking your answers. It works best if you first try this on your own, okay? Now, number 2, I want to make sure, even though like at the end of the day, you take a Keystone exam or whatever, an SAT exam, you pretty much have your choice. But I want you to know what the substitution method is, so I need you to, obviously showing your work, I need you to do the substitution method and show those steps, or at least show enough steps where I can tell you know what the heck you're doing. So here are all my steps. Now remember, in order to even do the substitution method, one of the equations has to be telling you what x equals or what y equals. Neither of these are at first. So I, kind of like trying to pick my easiest path. I decide that it's going to be by far the easiest thing to do to solve this first equation for y, because all you got to do is move that 4x to the other side. That's it. So, I solved this first equation for y, and now I can plug that whole quantity in for y in the other equation. And from here, you can just kind of take it away and let that play out, because now you're just solving this for x. You're just solving an equation for x. Distribute, combine the x's, minus 3 to the other. Wait, what in the heck is going on here, man? Wow. Why did I... Do you see this, gang? Why did I do this? I don't need this entire line, do I? Because at this point, you subtract 3 from both sides, and then you divide both sides by negative 4. Okay? And you end up with x equals positive, 1.5 or 3 halves. And then once you have x, just like you always do with solving systems of equations with these algebra methods, once you know what x equals, you're going to plug that in somewhere so you can figure out what y would equal, And in this case, I think I plugged in this x value into this one. So negative 4 times 3 halves is negative 6, plus 1 is negative 5. So your final answer is 3 halves, comma, negative 5. Number 3, I wanted you to solve by the elimination method. I call like in textbooks at least, it's usually called the elimination method. Of course, I sometimes refer to it by a nickname, the addition method. But so you got to use that method, which means everything's got to be lined up, which it is. But then you need to add the equations together, but only if there's opposites with the x's or the y's. Now, it would have been nice if there already would have been opposites, but no, negative 2x and positive 3x, not perfect opposites. They're not going to cancel out. Neither will positive 5y and positive 4y. So you have to multiply whatever, to either one of the equations or both of the equations to make either the x's or the y's opposites. So it looks like here I'm choosing the x's. Okay, you could have chosen the y's. Okay, there's numerous ways to skin the cat here, but so I multiplied this equation by 3 and this equation by 2. See, times 3 using the old school multiplication symbol. Times 3 times 2. The entire equation, even though I'm really just wanting to turn this term into a negative 6x, and I want to turn this term into a positive 6x so that they're opposites. But remember, you're multiplying. You can't just do that. The only way to do it legally is you have to multiply the entire equation, left side and right side, by 3. And the entire equation, left side, right side, by 2. And so when you do that, it turns this equation into this, and this equation into this. And now that there's opposites, and one of the variables are going to be eliminated, now you can add the equations together. 15y and 8y is 23y, 27 and negative 4 make positive 23. Solve this for y, divide both sides by 23. So y equals positive 1. And again, once you know what one of the variables is, you use that and plug it in. Looks like I plugged 1 in for this equation, in for y. And I was able to then solve for x. So final answer, negative 2, comma 1. Number 4, you can use the method of your choice. You could use the method of your choice. I chose the elimination method. You could have chosen something different, but whatever you ended up doing, your final answer should have still ended up being 1 comma 1/2. So you don't have to do it exactly how I did it, as long as you end up with 1 comma 1/2. But if you need a quick rundown of what I did in this elimination method, I chose to go after the y's. I could have chosen the x's, but if you notice, hopefully you realize and understand what I mean when I say making the y's into opposites was less work, because I only needed to change this to a negative 4y, and so I multiplied this entire equation by negative 2. because that's going to make this into a negative 4y. But this also becomes a negative 6x, and this also becomes a negative 8. This equation didn't have to change. And so now that I have this system and the y's are going to cancel out, I add the equations together to get to here, which opens up an easy door to solve for x, and I get x equals positive 1 by dividing both sides by negative 11. And once you know that x equals 1, looks like I chose to plug this answer back into here so I could figure out that y would equal 1/2. And so 1 comma 1/2. In number 5, it looks like, when I noticed that the second equation was telling you what x equals, that's a big, red flag. I don't know if that's the right term. That's a big indicator. I feel like there's a better phrase. Like that's a pretty good indication, whatever. It's a good indication that what you probably want to do is substitution. I chose substitution. You didn't have to choose substitution. You could have moved the 2y over to the other side, lined everything up, and then went from there, but I noticed that it's telling me that x equals 2y minus 5, so I went with substitution. And so I could plug 2y minus 5 in for x in the other equation to get to here. If x is equal to 2y minus 5, that means x and this quantity are interchangeable. So I replaced this x with what it's equal to, 2y minus 5, and that's how I got this. Once you have this, you can now just solve it as a basic equation, solve it for y. Okay? So I distributed, you probably can't hear that, but there are some fire trucks or something outside the school right now, or something like that. Anyway, so distributing gets you negative 6y plus 15. And then, combining like terms on the one side, and then getting y by itself, subtract 15 to the other side, divide both sides by negative 2, and we end up with y equals 4. As always, once you know that y equals 4, you can plug it into, I guess here was by far the simplest. Plug 4 in for y, and so x equals 2 times 4 minus 5, so 8 minus 5, 3. So final answer, x equals 3, y equals 4. Boom, bam. In number 6, we sort of up the ante. It's poker lingo. And we do systems of inequalities. Greater than, less than or equal to. So a system of two inequalities. Okay? These are both linear inequalities. No absolute value, no v's. You got to be able to classify and recognize what's what. Okay? So remember, with a system of inequalities, you're just going to graph both of them in the same plane, shading lightly and all that kind of stuff, because, you're not going to really darken in your shading until like the final answer. So this first inequality was good to go. I already know the y-intercept of 4 and the slope of negative 1 over 3, and you gotta remember, these are a lot of points you're going to lose across the whole test if you do not know when a line or v is supposed to be dashed and when it's supposed to be solid. All right? Greater than is a dashed line. If it would have been greater than or equal to, it would have been a solid line. Please be know that like the back of your hand, as they say. So this shading, greater than, and you also, speaking of losing major points, if you don't know what side to shade on based on the symbol, you're in big trouble. Or how to know what side to shade, anyway, test points and all that are other ways. But a greater than means you shade up, above. So you shade above. And with this guy, we had to solve for y really quick. adding 4x to the other side. So I get to here. Now I know where to put my line and what the slope is going to be and all that stuff. So 1 and then up 4 over 1. And since this is a less than, the line is dashed. And also since it's a less than, we're shading below. And so where the shadings overlap is right here. This is like your final answer, the final where you would like darken it in, okay? Like the final shaded area is right here, okay? You don't got to go super dark, but whatever. That's the final answer. Number 7, it's the same basic thing, but now we're tossing this one in there, which you should recognize as a V graph because of the absolute value. So this V, when you okay, like where's the vertex? There was no, since there's nothing here after the x, there's no shift right or left, and this -2 means we shift it down 2. So from this vertex, there was no shift left or right, but there was a shift down of 2. So there's the vertex, and then you notice this negative out in front, technically a -1. Since it's a negative number, the V is upside down, and your slope would be technically like -1, like down 1 over 1, and since it's a V, we go in both directions. Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, okay? But that negative basically means the V is upside down. And it's a greater than or equal to, which means your V is solid because of the or equal to, and because of the greater than means we shade up. So the very light shading, at first would have been above the V. Now this one is a line. It doesn't have absolute value. So you solve it for y, and then you get your y-intercept of -1, your slope of up 2 over 3, and it's a solid line, and you're going to be shading below, because of the symbol, below the line. And then the final shading for your final answer would be this area, okay? Basically like in between the V and the line. And the final question, right? That's right, final question, is going to look like this. Classify, I believe it is, let me think. Will it be exactly like this? Classify. Yeah, it should be. Oh, maybe it'll be a okay. If it's not exactly like this, it's going to be close enough. Where you might have to do a matching. The bottom line is you need to know what independent means, and dependent and inconsistent. All right, see this problem exactly here is like kind of multiple choice, But you need to know, so write this down. You need to know that independent is where you're going to end up with one answer. Remember, these are lines. These are back to being equations. So these are just lines, okay? And if it's independent, the lines have crossed at one point, so one answer. Dependent is when the two lines are like coinciding lines, and it means like there's infinitely many answers. It was like the same exact line on top of each other. Inconsistent means that there's no answers at all. And if you graph the two lines, it means they're going to be parallel, of course, because they don't cross anywhere. They don't share any solutions in common, so there's no solutions to the system, So you have to kind of know that. You have to know what all three of these mean. And you also might have to know how to, take a system of two equations and figure out what it is, So you just have to kind of make sure, here's what you got to do. You got to make sure both of these are solved for y. This one already is, but this one needed to be, subtract 2x to the other side, divide both sides by 4 to end up with this. And then you compare the slopes and maybe also the y-intercepts of this and this. And when you notice, like in this situation, they're exactly the same equation. It's got the same slope and the same y-intercept. So the answer to this particular number 8 problem is what? It's going to be dependent. These are exactly the same lines, and so there's infinitely many answers, and it's dependent. If you would have ended up with like a +7 here, or like a -3, but still the same slopes, that would have been parallel lines, and you would have chosen C. If you would have gotten like two equations with completely different slopes, like this would be like -1/2 x + 2, but this would have been like -5x + 2, or -5x - 3, or +4x - 6, whatever. Two completely different slopes, then you would have chosen A, independent. So, that's what you got to be able to do for the test. Happy studying. And as always, if there's still any lingering questions, please ask the next time you see me.